All right, good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. We are about to get into some exciting things dealing with the 30, 60, 90 triangles. But before we do anything with the 30, 60, 90 triangles, I want to first recover or review the 45, 45, 90 triangles. And so as we take a look here, remember the rules to the 45, 45, 90 triangle. So I'm going to go ahead and do something like this. 45, 45, 90 triangles. The rules that need to be covered would be this right here. Okay. 45, 45, 90 triangle. My phone's ringing. I'll be back. Oop. In one second. Actually, you know what? Let me give you the rules here. And you guys go ahead and see if you can figure out those other three lengths in the two triangles. All right, so I'm back. I know that wasn't much time there. Hopefully, if you haven't got a chance to work those out on your own, I would go ahead and do that. Main reason is because I know how to do them. I want you guys to know how to do them, and if you don't, I want to know exactly where those gray areas are, so you can kind of self-assess yourself, figure out where exactly your struggle points are. But one thing I want to encourage us to do, even if you've already filled in all the answers here, is to make sure that we put down here that we are working with a 45, 45, 90 triangle. So if you haven't already done that, go ahead and show that here. The reason why I'm having us do that, which seems kind of redundant, all the triangles we're working with are these type of triangles. Well, the reason why I'm having us do this is because I want it to be solid in your mind that the only time I use these principles are when I have this special type of triangle. If I don't have this special type of triangle, then I can't use those principles. All right, so from here, I'm going to go ahead and plug in my three lengths, x, x, and x radical 2. Okay, and I'm going to do that for all of my triangles right now to make sure that I know specifically what each side length is going to be. Okay, and so once I have orientated myself, I think that's a word, oriented myself correctly as far as our rule is concerned, I can go ahead and figure out what x is going to be and apply it correctly. So, for example, in this first problem, it's real simple. If I just divide both sides by radical 2, you end up with 4, and that's what x equals. So I can go ahead and plug in x down here because that's what x is. And I can plug in x right here because that's, again, what x is. Okay? So hopefully, when you got a chance to try this a couple seconds ago, you automatically knew that. Or if you didn't, you're getting to the point where, that's pretty common sense. It's simple. In the next one, I plug in what x is, which was given to me right here. And then I'm going to plug in it up here. And that's how long my hypotenuse is. All I'm doing is plugging in the 7 for the x since I know what x is already. Okay? Now, like the very first triangle, I don't know what x is. And so I have to figure it out. So what's the operation that's occurring between these two? Well, just like the first one, it's multiplication. So I'm going to divide both sides by radical 2. Okay, and that's going to be what x equals. Now from there, remember we can't leave this radical down there. That's just one of the rules that we don't want to operate under. And so we're going to go ahead and multiply by radical 2 over radical 2. We're going to rationalize that denominator. Okay? From that point, we can just work this out. 12 times radical 2, not a trick question. Just 12 radical 2. Okay? And what's radical 2 times radical 2? Well, that's just 2 as well. Okay? It's just 2. Now, to finish things off, I'm going to go ahead and simplify that fraction there. 12 over 2 just becomes 6, and then the radical 2 comes along for the right. We only take a look at, we only divide like with like. So the 12 and the 2, those would be considered like terms. That's why we cancel them out or we simplify them. The radical 2 is an unlike term, so it just has to come along. Okay? So, with that being said, hopefully you had most of those correct to a high degree, and we are now going to go down to the bottom of our page and take a look at, we're actually going to write down the rule that we're working under today. So today the rule that we're working under is a 30, 60, 90 triangle, okay? Different than the 45, 45, 90. Now, I have had some students come up to me and say, in the past, I thought that the only type of right triangle there could be would be a 45, 45, 90 triangle. And the answer is no. There could be anything that adds up to 90. What I mean by that is this. In a right triangle, okay, these two angles, all they have to do is add up to 90. So you could have 70-20, 50-40, 60-30, 72-18, any combination of two numbers who are complementary would, that could be a right triangle, okay? But these two that we're talking about the last 2 days, the 45, 45, 90 and the 36, 90, they're special. We see them often, a lot, and so we want to make sure that we know our way around them because they've got simple rules that can apply to their side lengths. So the first thing I want you to do is to go ahead and draw out an equilateral triangle. Now, as you draw out the equilateral triangle there, I want you to be thinking to yourself, what else do we know about this equilateral triangle? What else would be true within this figure? And I would hope that one of the first things that would pop up in your mind would be the fact that each angle has the same measure, and that measure is going to be 60 degrees. Okay? Now, in order to understand the concepts we're going to be talking about today, the 30, 60, 90 triangle, I'm going to go ahead and take a line from the vertex of my triangle and drop it down perpendicular to the base of my triangle. Okay? Now the question I want you to think about is this. What does that do to this angle up here? The vertex angle. It bisects it, right? Cuts it in half. Now, something to think about is this. Why is it cut in half? Well, right now these two triangles are congruent to each other by hypotenuse leg. Hypotenuse leg. Okay, so yeah, they're congruent to each other. Now I'm going to pull out that 30, 60, 90 triangle so that we can more clearly see what is happening within this triangle here. So if I go ahead and do this, that's all we know as of right now. Okay? Now the next thing I'm going to do is I'm going to tell everybody that each side length has a length of 2x. So I'm going to go ahead and make that this side length is 2x right here. Okay? And so from there, I know that this length has to be 2x as well. Okay? Now, if each side length has a length of 2x, what does that side length right there have to be? Well, if the two triangles are congruent and the whole length is 2x, then this has to be x and this has to be x. They both have to be the same length. So this is the length of x over here. Okay? Now from there, the question then becomes, how do I figure out this third side in terms of x? And this is how we're going to do it. I'm going to label that third side a length of a, and we're going to solve for a using the Pythagorean theorem. Now I want you to pay close attention to how I wrote the Pythagorean theorem out there with the hypotenuse being in parentheses. Why is it in parentheses? Because there's two parts to it, and both parts need to be squared. Okay? So if I go ahead and solve for a, you end up with this and this. Okay? And so the product there, 2x times 2x is 2 times 2 is 4, x times x is x squared. We get 2x squared. Okay? Now to solve for a, I'm going to go ahead and put a 1 in right there. And we know that we're going to subtract this from both sides. So if I subtract 1x squared from both sides, we end up with this. The a squared just comes down. 4 minus 1 is 3. And the x squared just comes along. Okay? 4x minus 1x is still 3x. We didn't do anything to the x or its exponents. So 4x squared minus 3x squared is still, sorry, it's the wrong. 4x squared minus 1x squared is still 3x squared. Okay? Now next, I'm going to go ahead and solve for a by square rooting both sides. All right? So in the end, in order to understand what's going on here, I'm going to write this in expanded form like that. Okay? And so to solve for a, we are going to simplify this by pulling out the x from underneath the radical. And that right there is the length of the longer leg. Okay, x radical 3. So those are the three different side lengths in terms of x that we're going to be working with. And so let's do this. Let's go back up to your first couple problems here. Not the 45, 45, 90, but the 30, 60, 90. And let's go ahead and label these side lengths. If I go ahead and label this, I want you to get down the angles first. The angle here is a right angle, okay? This angle is the 60, opposite the longer leg. This angle is the 30, opposite the shorter leg, okay? Over here, here's 90. The shorter leg opposite would be 30. The longer leg opposite would be 60. Okay? And then this one, here's the right angle. Longer leg opposite would be 60. Shorter leg opposite would be 30. Okay? Now, after you've done that on all your triangles, because we're working with these specific type of triangles, if you're not working with that specific type of triangle, you need to figure out what type of triangle you are working with. Okay? And so from there, I'm going to go ahead and label everything. Now, if you notice down here, down below, where you took your notes, goodness, got another phone call coming. Excuse me. All right, sorry about that. My phone rings like once a year and it rings twice in one class period. Anyways, what I was about to say is after you've identified the angles within your triangle, you have to know that you're working with this type of triangle. If you're not working with the 30, 60, 90 triangle, don't apply these rules here, okay? But after you've done that, across from the right angle is always 2x, okay? So if you look down below where you have your notes, you notice the hypotenuse is always 2x. So what I'm going to do on all of my triangles up here, I'm going to write down 2x, okay? The next thing I'm going to do is I'm going to go across from the 30-degree angle. The shortest leg is always x. Okay, so opposite the 30-degree angle, the shortest leg is x. Opposite the 30-degree angle, the shortest leg is x. Okay? And then opposite the 60-degree angle is going to be x radical 3. Opposite the 60, x radical 3. Opposite the 60, x radical 3. Okay? Now from there, what color do I want to use? Maroon? Okay. From there, it's simple, just making sure you've got everything in the right spot and solving for x correctly. So for example, here I've got x. So x is right here. If I plug that in, I get a length of 14. Okay. Here I've got x. I plug it in. And I've got 7 radical 3. That's my length there. That's as simple as it is. Okay? Now what you're going to notice on the next two problems, we don't have x. The question will be, how do I get x by itself? Well, if I divide 3 by 2, x will equal 7.5. And that would be this length here, because that's x. Okay? And then from there, since x is 7.5, I can just plug that in. And there's the length of that leg. Okay. Going to the last problem, we don't have x by itself, so like we did in the problem just above up here, even though it was a radical 2, it's the same concept. We're going to divide by radical 3. We're going to divide by radical 3. And so what is x? X is just 6. So this length here is 6, and this length here is 2 times 6, which would be 12. Okay? So length of the hypotenuse there is 12. So again, those first three were very basic and simple. If you need help, come and see me, see somebody, but make sure you get that understanding down. Now, we're going to move to the back side now and take a look at the back side where the problems get a little bit more complicated. Okay? So on the back side, the first thing I'm going to do is just like on the front side, I'm going to identify my right angles. I'm going to identify my angle measurements. Okay, hopefully we can see that that's more acute than the 60-degree angle. Okay, this one is opposite the longer leg is 60. Opposite of the shorter leg is 30. Okay, so once I've got my angles identified, then I'm going to start plugging in the x radical 3, and the 2x. So opposite the hypotenuse is always 2x, like we saw on the front side. Opposite the hypotenuse, 2x. Opposite the 30 is always the x, the shorter leg. Opposite the 30 is the x. Okay? And then opposite the 60 is x radical 3. Opposite the 60, x radical 3. Okay? So pretty simple once we've got it all laid out. Now, here's the question. In the very first one there, I need to figure out what x is going to be. Okay? Right now we've got 2x equals 12 radical 2. How do I get x? How do I figure out what x is? I'm going to divide by 2. Okay? So this is going to end up being x equals, now dividing like terms, 6 radical 2. That's my x value there. All right. Now, if that's my x value, and I take that x value, and I plug it in right here, 6 radical 2, that's my x value. This radical 3 has to come along. Okay, so multiply by radical 3. That gives me 6 radical 6. Okay, and there are no perfect squares in 6, so I can leave it as radical 6. Okay. All right, now, for this one, we already know what x is, which is awesome. All I have to do is plug it in. So I'm going to plug in 4 radical 3 in for the x. That'll give me, again, multiplying only like terms, 8. Nothing to multiply with the radical 3, just 8 radical 3. You could always test that in your calculator and see if it comes out to the exact same decimal. Do 2 times 4 radical 3 and then do 8 radical 3 and make sure it equals the same thing. For this one, since this is x, I'm going to put in that x and multiply that by the radical 3. So you'll end up with 4 times radical 9. Well, we all know what the square root of 9 is. That's 3. So the length of that side is just going to be 12. Okay? So, again, it's not hard if you identify the angles and put the variables in the correct location. Today I've seen a couple of people that did not put the variables in the correct location. They knew what they were doing, but they mixed up the side lengths. Okay? For this one, here's my right angle. Here's my 60-degree angle. Here's my 30-degree angle. Okay? I'm going to go ahead and label my 3 sides. Opposite the right angle is 2x. Opposite the 30 is x. And opposite the 60 is x radical 3. Okay? Now, the algebra on this one's a little bit more complicated. The geometry part's not bad, but the algebra is more complicated. I need to solve for x here. So I'm going to go ahead and divide by radical 3. And right now I get this. X equals 7 over radical 3. Okay? Now, this should look very similar to what you guys had on that third practice problem when we did the 45, 45, 90 triangles. We want to go ahead and rationalize this denominator. So I'm going to go ahead and multiply by radical 3 over radical 3, which would give you 7 radical 3, 7 times radical 3, over what's radical 3 times radical 3? That's just 3. Okay? Now, I can write it like that. I can write it like this. Or I can write it like this. I think my preference is the last one there. I'm going to sneeze. Whew. Okay? But that is the length of x, 2 1/3 radical 3 or 7/3 radical 3. Okay? All those are the same. Now, if I double that, because this is x, if I double that, we end up with 2 times 2 is 4. 2 times 1/3 is 2/3 radical 3. Okay? So, again, now, if you doubled one of the other ones, it would be this. This is equivalent, 14 radical 3 over 3. Okay? Because we're multiplying it by 2 over 1, not 2 over 2. Okay? Now, for these last two problems here, or last couple of problems here, guys, what I want you to see is you've got both what we learned on the other day, the 45, 45, 90 triangles, and then the 30, 60, 90 triangles, all coming together as one. okay? And so what I would do, unless you've got a trained eye, is to go ahead and draw these triangles separate. So I'll draw the 45, 45, 90 triangle separate. Okay, and I'll label the 3 side lengths as they're given. And that one's 5. Okay, so I hope you can see that I just drew this triangle over here, over there. Okay, and I'll draw the 30, 60, 90 triangle separate. Okay, and here's the 2x, the hypotenuse, the shorter leg, and the longer leg. Okay. So from there, if we start to work out this one's pretty simple. The x is 5, 5, and 5 radical 2. That was easy peasy lemon squeezy, right? It's so simple. All right, 5, 5 radical 2. Okay. Now from there, I would go ahead and take the value that we have here, which is the same as this one over here, and put it down right there. Okay. Now it becomes a simple algebra problem to figure out the other 2 side lengths. So we know that we need to get x by itself here, divide by radical 3, and we end up with this, x equals 5 over radical 3. Okay. Now again, we can't leave it like that, so I'm going to put this down, times radical 3 over radical 3. What that gives me is 5 radical 3 over 3. Okay? You can leave it like that. You can also write it as 5/3 radical 3 or 1 2/3 radical 3. Okay? So that's what x equals, and so I can write that down here, 1 2/3 radical 3. Okay? Now if I double that, 2 times 1 2/3 radical 3. We end up with 2 4/3, which is another 1 1/3. So 3 1/3 radical 3 is the hypotenuse length there. So W, again, is 3 1/3 radical 3, and Z is going to be 1 2/3 radical 3. Okay? Whew. That's a lot of work right there. All right, now, to finish things up, I think we've got 2 more problems here. Let me see. Okay. Again, if I were you, I would draw the triangle separately. If you feel confident enough to do it without drawing it, this would be x, this would be 2x, and this would be x radical 3. Okay. And so if that's x, doubling x would give me this side, so r is going to be 8. And multiplying x times radical 3 would give me q, so this is going to be 4 radical 3. Okay? Now, this is a 45, 45, 90 triangle, so with a different color, I'll go ahead and put down the rules there. This length right here is x, that's x, and this is x radical 2. So again, 4 radical 3. This is also going to be 4 radical 3. And then x radical 2, if I plug in the x, which is 4 radical 3, times radical 2 would give me 4 radical 6, and that's the length of the hypotenuse there. Okay? To finish things off, do real quick because I've got kids coming in here for the next class. Come on in. Come on in, Eli. You can go ahead and move this over to become 2 radical 3. The big thing we'll be stressing over the next couple of days, if they give you a 30, 60, or 45 degree angle, there's a reason why it's there. Okay? So I'm going to make this 2 radical 3, and we know that this side length is x radical 3, this one's x, and this is 2x. Okay? So if we go ahead and solve for x, dividing by radical 3 here, you're going to end up with x equaling 2. Double x is 2, so 2 times 2 is 4. Okay? And if this length here is 4, and the whole length is 5, what's left over right here is 3, and that's how you figure out those missing parts there. I apologize for it being so rushed here, but with shortened class periods today, I didn't have a whole lot of time to do that. So hopefully all that made sense. If you have any questions, come see me or talk to somebody else and get it figured out. Hope you have a great day, and I'll see you tomorrow. Good night.